Today we're going to study logarithmic properties. We started an investigation in class. This lesson goes through several of the problems from that packet. Let's start on page 1. Part 1, number 1, said to evaluate these expressions using your understanding of logs. So number 1, we have log base 2 of 8 plus log base 2 of 4 equals what? So we start with log base 2 of 8, that's 3. Log base 2 of 4 is 2. 3 and 2 equals 5. So over here we want to know log base 2 of what is also equal to 5. So we're looking for a pattern here, so use the log loop. 2 to the 5th power is equal to 32. Do that for problems 2, 3, and 4, and look for a pattern. And we can see that the 32 is coming from multiplying 8 times 4. In general, that property is log base b of x plus log base b of y equals log base b of x times y. This is known as the product property of logarithms. Let's use this rule to solve problem 6 that we were not able to do before without a calculator. Here we have the sum of two logs and they have the same base. Notice the rule, we must have the same base. So we are going to condense this log by multiplying the 12 times the 3. So this turns into log base 6 of 12 times 3. That's equal to log base 6 of 36. And that is equal to 2. Let's look at the next property of logs. Turn to page 2 in your packet. The next property is the quotient property of logarithms. Look at problem 9. We have log base 5 of 625 minus log base 5 of 5 is equal to what? Well, log base 5 of 625 is 4. Log base 5 of 5 is 1. 4 minus 1 gives us 3. So looking for a pattern, we want to know log base 5 of what is equal to 3. So we can use the log loop. 5 to the 3rd power gives us 125. And do the same thing for problems 10, 11, and 12. Looking at the pattern, we see to get the 125, we take the 625 and divide by 5. In general, this property can be summarized as log base b of x minus log base b of y equals log base b of x divided by y. This is known as the quotient property of logarithms. Let's use the new rule to solve problem 14. Log base 6 of 72 minus log base 6 of 2. We could not solve this problem before without a calculator. But with our new properties, we can condense this log. We are subtracting logs, so to condense this into one log, we divide 72 by 2. So since the bases match, we have log base 6 of 72 divided by 2. So that's log base 6 of 36, and that is equal to 2. Let's look at the third rule now for logarithms. The power property. Turn to page 3 and look at problem 17. We want to evaluate log base 2 of 4 to the 3rd power and look for a pattern. So 4 to the 3rd power is 64. And log base 2 of 64 is equal to 6. So we want to look for a pattern. What times log base 2 of 4 is also equal to 6? So the bases here are the same of the 2. The argument 4 stays the same. We know log base 2 of 4 is 2. What times 2 equals 6? The answer is 3. Do the same with numbers 18, 19, and 20, and we can see the pattern is that the exponent here has been rewritten out front of the log. So we have the 3 can be rewritten in front of the log. This property is known as the power property of logarithms. In general, it can be stated as log base b of a to the c equals c times log base b of a. I call this property the exponent falls off the log rule. So here we have the exponent c, and it can fall off the log and be written out front and be multiplied by the log. So let's try problem 22. Let's first rewrite this with an exponent of 1/2. The square root is the same as 1/2. So we have log base 10 of 1,000 to the 1/2 power. And now we have a log and we have an exponent. And according to the power property, the exponent here can fall off the log. So this is equal to 1/2 times log base 10 of 1,000. And log base 10 of 1,000 is 3. 3 times 1/2 is 3/2. And you can try out the other problems, numbers 23 and 24. Look at the bottom of page 3 and we'll summarize the 3 rules of logarithms. The first rule, the product rule, is log base b of x times y equals log base b of x plus log base b of y. The quotient rule, log base b of x divided by y equals log base b of x minus log base b of y. And finally, the power rule, log base b of a to the c equals c times log base b of a. Let's turn to page 4 and practice some problems on this page. We'll start with number 1, expand each logarithm. Part A, we have log of a squared c. This is a good time to mention that logs do not have to have a base written. The rules of logarithms hold for any base. We'll learn later that if there's no base written, it's implied that it's a base of 10. However, for the purposes of expanding and condensing logs today, it is okay that there is no base written here. Again, the base can be anything, and these rules will still apply. Okay, to expand here, we see we have a product of a squared and c. So we're going to use the product rule to expand that by adding the logs. So this is equal to log of a squared plus log of c. And then we're going to use the power rule. The exponent 2 can fall off the log. So this will equal 2 times log of a plus log of c. And this is our final answer. This is expanded. Let's try one more of question 1, part B. We have log of c cubed divided by b. So we see here we have a quotient, so we want to use the quotient rule by separating the logs with a subtraction. So we have log of c cubed minus log of b. Now, since we have an exponent, we can have that exponent fall off the log. So this is equal to 3 times the log of c minus the log of b. So this is our final answer. Let's move down to question 2. We're going to do the reverse of question 1. We're going to condense each expression into a single logarithm. Let's look at part A, 2 log of b plus 3 log of c. Well, first we see that we have coefficients in front of a log. Those can always be brought back up as exponents. So the 2 can be brought up as an exponent, and the 3 can be brought up as an exponent on a single argument. So we have log of b squared plus log of c cubed. Now, since we have a sum of 2 logs, we can condense that using the product property. So we can condense this to log of b squared times c cubed. This is the product property in reverse. So this would be our final answer. We have condensed into a single log. Let's skip ahead to part C. We have 2 log of c minus 3 log of a plus log of b. We'll start by using the power property and put the exponents back up on the logs. So put the 2 up as an exponent and put the 3 up as an exponent. So we have log of c squared minus log of a cubed plus log of b. Now we'll work in the parentheses. We have a sum of 2 logs. So we know we can condense those using the product property. We'll condense those into log of a cubed times b. So what we did here is, here we added the 2 logs and we can combine them using the product of a cubed and b, and then we left the log of c squared and the subtraction alone. Now we have 2 logs that are subtracted. We can condense those using the quotient rule. So we have log of c squared divided by a cubed times b. Again, here we use the quotient rule to condense, and here we have our final answer. The last problems we'll look at are the multiple choice questions. I have a few hints for you to get started on those. Skip down to number 5. Number 5 says if log of 2 is equal to m and log of 6 is equal to n, then log of 48 equals what? Well, to do this, you want to try to break 48 down into its prime factors. So we know 48 is equal to 8 times 6. And we have a log of 6, so we'll leave that. That's good. 8 is equal to 4 times 2. And 4 is equal to 2 times 2. So we can rewrite log of 48 as log of 2 to the 3rd power times 6. From there, you can use your log properties to break that down. Once you have log of 2 and log of 6, you can substitute in your m and n. The last problem, look at problem 6. The expression 2 plus log of 10x, log base 10 of x is equivalent to. My hint for you is to see that we need to condense, looking at our multiple choice solutions, into one log. And this log has a base of 10. So let's see what 2 is equal to with a base of 10. Well, we know that log base 10 of 100 is equal to 2. So there's a hint to use in your substitution.